aqua, water, water, council pot, H2O. What a brilliant substance. Where would we be without water? The Earth seems to be absolutely full of the stuff. 1.3 billion cubic kilometres of it, in fact. Enough to fill 560 billion Olympic-sized swimming pools. 97% of it can be found in the oceans that cover 71% of the planet's surface. 55% of an average woman's body and 60% of a man's is made of water. We drink it. We use a whole load of it through our food and fashion chains. 2,400 litres are used to make a hamburger. 10,000 litres to make a pair of jeans. All this water has been cycling through the planet's systems for as long as it has been here. Billions of years. So the water we drink is the same water the dinosaurs drank. Yet all that water came from space. In the early solar system, as the Earth formed, it was simply too hot and energetic for water. So the Earth formed as a barren, tumultuous volcanic rock. The water on Earth resembles the water found in comets. Small icy bodies that formed in the much cooler, calmer outer solar system. Over incomprehensibly long periods of time, an incomprehensibly large number of comets must have collided with our Earth to bring us all that water. And water is odd. It is a very weird substance, and we are very fortunate that it is. Normal things all behave the same. You heat them, they get more energy. They move around more, and they take up more space as they transition from a solid to a liquid to a gas. The solid form of a substance should sink in its liquid form. It's good news for our ocean circulation and sustaining life on Earth as we know, yet bad news for the Titanic, that ice floats on liquid water. Water is made up of one molecule of oxygen and two of hydrogen, H2O. The oxygen molecule brings 8 electrons to the party, and the hydrogens 1 each. The distribution of the electrons means the hydrogen molecules get pushed to one side of the oxygen, leaving one end of the water molecule slightly negatively charged and the other positive. The result is that with no other influences on the water molecules would align themselves and ever so slightly attract each other. When water is in its liquid or gaseous forms, the molecules have enough energy to overcome this attraction, although liquid water is a tiny bit sticky. But when it cools, it loses the energy and the molecules will align and take on a crystalline structure. This takes up more space than the same amount of liquid water, so it is lighter and it floats. Can you imagine how the world would look if water was not so odd? I've been Flood Skinner, this has been Distracted Geography. Please like this video and subscribe to the channel.